Alright, products and quotient rules with trig functions. So we've got two examples to get through here, and really it's just applying stuff we already know. So in theory I would expect you to do this anyway, but I'll go through an example just in case you've got some anxiety trying these. So for our first problem, h of x, I'm going to write this as u times v, where u equals 2x, the thing that's times and cos, and v equals cos x. And I'm going to have to differentiate both those functions. So du by dv is 2, and dv by dx is negative sine x. And so my product rule says that I can apply the product rule, I suppose, to differentiate this function. So I'll just quickly bring up the product rule again. So we have, if we zoom in on it here, so we have u times dv by dx. So u, which is 2x, times the derivative of v, so that's negative sine x, plus v, which is cos x, times the derivative of u, that should be with respect to x, I keep on making that mistake, which is 2. Okay, so just notice that I've put stuff in brackets. It's a good habit to get into when you're applying the quotient rule. The product rule. Okay, so let's tidy things up. So we've got negative 2x sine x plus 2 cos x, and we could factorize that, I suppose, if we wanted to, and we could have 2, maybe negative 2 bracket x sine x minus cos x. So the same old story, NCA there, and the mathematicious version down here. I shouldn't really say things like that while I'm trying to write this out. So there we go, mathematician's version down there. Okay, well that was quite quick, so I might just go straight on to the next example anyway. So here we're looking at one applying the quotient rule. So I'm going to say that h of x is u over v, where u is sine of x and v is 3x. And so I'm going to have to differentiate both these functions. So du by dx is going to be cos x, and dv by dx is just going to be 3. So now I'm going to write out my substitution for the quotient rule. So let's just bring up the quotient rule again. So there's our quotient rule. Let's get rid of that. So we've got v times du by dx. So we'll write that out. I'll write it on top. V times du by dx, which is cos x, minus u, which is sine x, times dv by dx, which is 3, and that's all over v squared, so all over 3x squared. Just notice where I'm using brackets as well, particularly here. A lot of students in that situation write out sine x times 3, and they really stuff themselves up, because that is quite different from what I've written in brackets. So let's tidy this thing up a little bit. So we've got 3x cos x minus 3 sine x all over 9x squared. Let's take out a common factor out of the top. So we've got 3x cos x minus sine x all over 9x squared. And so we can simplify our 9 and our 3 a little bit. And so a fully simplified answer is going to be x cos x minus sine x all over 3x squared. So same old story. This is for NCA, just the simple substitution, and this is for all those mathematicians out there who want nothing less than perfection and prefer working at six-figure salary jobs rather than KFC. Okay, so have a go at those exercises there, and I'm sure you should find this just simple lead on from the product and quotient rules.